Welcome as I attempt to do a product review on the EGON DC Hub. Put very simply, the EGON DC Hub shrinks all of these components and makes them into a single component. Okay, one. All of those things, and when I say all, I'm talking about everything you see in this photograph is replaced in one unit. What does that do? It significantly reduces the amount of space you need to do an installation. This is going to be a difficult one because, well, disclaimer, to be honest, I was directly involved with the design of the EGON DC Hub. But what I want to do here is I want to help you decide whether to buy one or not. And there are cases where you shouldn't buy one, where it's not going to give you any big advantages. Okay, it might give you a few, but at the cost. But I want to begin with who shouldn't buy a DC Hub. Now, if you are doing the installation yourself at home and let's think of a typical, you've got a fridge, you've got a light at the back, you've got a USB charging station. No, man, that's so easy to install. You just get an ordinary little fuse box and maybe a mega fuse and use Anderson plugs for your fridge. And you're going to do it for a fraction of the cost. You won't have the diagnostic capabilities of a DC Hub, but would you want to spend that extra money? I probably wouldn't recommend it to somebody. But now, once you're going to, okay, I want to do a compressor, I might have two fridges, a fridge and a freezer. I've got some exterior lights. I've got 3 interior lights. And I've also got some tally lights on the roof. And I've got another run. I want to run a cable to my front console because I've got some charging units in my console. And, I've got a rooftop tent. I'm definitely I'm going to need power in my rooftop tent. Then you're starting to get much, much closer to where the DC Hub really will give you some big advantages because of space and most significantly of all, diagnostics. Now, if you're getting a workshop to do this build for you, even the basic ones, I would say think clearly about the DC Hub because it's in one unit, it's going to save, and it does save, about, and I'm not exaggerating, between 60 and 70% on labor time. So that immediately pays for it. Bang! And you get the diagnostics. But here's the big thing. Here's the big thing. If you're starting off with a basic install, but you have dreams of adding this and adding that, I'm gonna add that. The DC Hub is a no-brainer because all you do, say you've put, I need another light at the back or at the right-hand side because I like to park on the beach and we need to light the camping area because we fish from quite close to the vehicle or something, and you're dreaming of doing this and you're going to add it later. How do you do it? You mount your light and you run a wire and you run a wire. Done. Run a wire. Done. Fusing's done. Earth done. Everything is done. Just run a wire. I want to add solar panels to my roof. I'm not going to do it now. It's a bit costly. Towards the end of the year. I know how you and I we talk. We think, I'm going to definitely put a roof, a solar. I need another blanket. Run the wires and plug it in. Solar, there. Unregulated solar, regulated solar. Just run the wires. So in terms of your build, your long-term view of your build, it's a no-brainer even if you're starting small. So the diagnostic ability of the DC Hub, a big question mark on it. Now these red LEDs are the diagnostic part of the EGON DC Hub. Basically, they turn on when a fuse is blown, but one of the questions we got, and several times, if I've got nothing plugged into that circuit, won't they just always turn on, confusing a diagnostics process? No. They do not turn on if nothing is connected to the circuit. So if it's a completely open circuit and there is no fuse, the light does not turn on. It turns on when the circuit has been completed. In other words, your wiring is completed, but there's no fuse or the fuse has popped. Then the light comes on, and only then. It is a proper fuse diagnostic process, and it's analog. There's no electronics here. All right. And there's a recent review by Harry Fisher from Fire to Fork, one of my favourite channels, and he's built another one, his second one, into his, in fact it'll be his third one, into his Land Cruiser 300. You should check out that video.
Now the wiring in this car does actually go through lots and like through the whole car. So everything is wired to a central hub, and that central hub is an EGON DC hub.
But he talks about the ease of the DC hub, and he got a company to do his installation, and the company has said, wow, this is really good.
The guys at Hunter had never installed a DC hub, and they said it was really easy.
They were impressed with it. They hadn't used it before.
Everything screws in. It's really, really simple.
And he said, his biggest praise of the unit was that because it's all in one place, it's so easy for me to do diagnostics if something stops working.
I have had a couple of little issues over the years with items in my car not working. And 100% of the time I can go to the DC hub and go, oh, that light's on. Or I can check it with my multimeter and go, yeah, that's getting power, so it's not the power supply, or that's blown a fuse or whatever. It makes my fault finding so quick. I'm not sitting there poking holes through bloody cables. I'm not sitting there trying to resolder something or pulling heat shrink off. Everything is just accessible.
Because it's all the wires, all of them. With the exception of large inverters, every single thing goes to one item, everything. And because of that, you go to one place. Now for workshops, that's quite a big deal, because if I'm a workshop and I'm doing electrical installation, you guys know they're never identical, never. In fact, very few workshops even have their own standardization. There you go, standardization in a box. You can then have fridge on number 1, exterior lights on number 2, etc., 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 all 10 of the 25 amp current fuses down the bottom there. So you can standardize it. The rest of it is pretty standardized because they're labeled. So you know if there's a fault with the solar charging, well, go and have a look at that part of the DC hub. That is where it's wired to, always. And that's the key, standardization. If you are a company building these things and you've got a fleet of cars going out, wouldn't you like, tell me if this would be helpful to you, wouldn't you like every single vehicle to be exactly the same? And even those with only a few bits of equipment attached to them and maybe would want to add some more later, and those are full rigs with very complicated electrical systems, wouldn't you like all of them to be exactly the same? So when the phone rings, hello, yes, we've got a problem and we're near Esperance and the so-and-so. Yeah, go to your DC hub, look at fuse 5, yeah, okay, and then I want you to look at the solar input fuse, and don't you think that's a good idea? Well, if you do, that's what this was designed for. If you think it's not really necessary, well then, how about just leaving diagnostics to the operator? DC hub. See when a fuse is blown. Now, I know I'm overselling it, but it's an amazing piece of kit. Okay, so now, all right, I'm going to pull myself back a little bit from the hype. All right, so let's talk about some failures that we had in developing the product. And I want to thank those people that were willing partners. We built approximately 20 into various people's vehicles. Harry Fisher was one of them. And we kind of thought, and we had tested it, we even tested it with 200 amps, managed to run through the thing for about 20 minutes before it caught light. So we felt that we had tested it sufficiently, but it turns out we hadn't. You can't test a product unless it's actually in the hands of the users. You just can't, because you'll always have unexpected challenges, and there were some.
I've been running one for, I guess it's close to 5 years in the Prado. I ran the prototype, and the prototype did have an issue, and then they fixed that, and they showed me how they fix it, which I always appreciate, because there are companies and they go, oh yeah, cool, we'll give you a new one. I'm like, no, is this going to happen again? They're like, I hope not. If a company does that, I'm out straight away. I'm like, no, I've got to find a new solution. I went back to EGON and said, hey, this happened, and they were like, oh yeah, that's right. You've got the prototype, don't you? Okay, here you go. Here's the production model, and this is actually our new and improved production model. And they showed me all the ways they changed it.
He had a fault because he was using very high charge rates over long periods of time, and we were starting to get warping of the board, heat buildup, excessive heat buildup.
And the exact issue I had was not only rectified, but rectified like 4 times over, as in they bulked it up to quadruple its capacity.
Because we're a small company, we produce on average 100 of these at a time. We can immediately say, uh-oh, what's going on? Okay, let's have a look. Get it back, have a look. We just gave Harry another one. Take another, here's another one. At the time, we were towards the end of the testing process of that prototype, and we had already arrived with our version 2. We're now at version 2.1, I think, on the DC Hub. And he never had that problem again, because we had solved the problem. And now we celebrated a couple of months back our 1,000th DC Hub sold. But our milestone is, drum roll,
we've now sold more than 1,000 DC hubs over the last years.
Another question that has come up quite frequently, and I think it's a concern, and it's a valid one. Why are you using these standard spade fuses, both the large ones and the small ones? Well, there's a very good reason that we wanted to make it, remember, it's simplifying things, not making things more complicated. I've got a broken fuse. We do have spare fuse holders, but I didn't put them in, maybe I forgot about them, and oops, I need another fuse. These spade fuses are the most common fuses worldwide. However, the connectors, and when I say connectors, I'm talking about something like this. All right? No. That and this, 2 different things. They look the same, they do the same job, different. So these on the DC Hub, we didn't build this for cost, we built it for quality. Okay, so when we went looking for spade connector clamps, we had to go far and wide to find. You'll notice that when you plug one of these things in here, I'm hanging the whole thing on one little spade fuse. I've got the clamp rates are very high, and in those areas where there is a lot of current, the high current flow points in the DC Hub, we have used 2 of them. And the reason for 2 of them, as opposed to 1 even bigger fuse, is that because of the potential voltage drop of this kind of connector, we have doubled the clamp, because there are 2 fuses doing the job of 1 fuse. Yeah? And that's how we did it. And so far now we must have, I would say we're probably sitting on 500 or 600 DC Hubs, the version 2.1 out there, and we have had a few comebacks. Now, but I'm going to explain to you what those comebacks are, because it's actually very, very important. Those of you who have got DC Hubs fitted in your vehicle, you can't, if you are in a high vibration environment, lots of corrugations, make your DC Hub one of your maintenance jobs. Every single one was because they hadn't tightened the clamp sufficiently. When wiring it up, make sure that when you clear and clean the insulation, that none of the insulation is going to be clamped. Okay, clean, neat, push it all the way in, and here's where the problems lie. And it is that the clamps are not tightened sufficiently. So I know a lot of you are not going to buy one of these, a Torx screwdriver, but I'm going to demonstrate now to try and help you understand what these represent. The 25 amp connectors, they require a 0.6 Newton meter, and I'm going to tighten it to 0.6 so you can see how much effort I'm putting into it, because there you go, nice and firmly tight. All right, now the 80 amp, which are these guys here, these are at 1.5, so I'm going to crank this up to, there you go, exactly 1.5. Let me demonstrate to you what that represents in terms of muscle strength, because I know how many of you are actually going to go and buy one of these. Not that many. Okay, so what does this mean? I'm now going to crank that up to 1.5 Newton meters, and I'm going to demonstrate to you how much that is. There you go. I hope that helps. All right, so these ones here, these are 3.5 Newton meters. Now this is going to surprise you, okay? Okay, I can't get it, but tighten it. Give it a good old. You're not going to break these things. These are, the quality of these connections is so good. The best thing though is to read on, and we have an extensive support system on the website where you can find out wiring diagrams for different DC-DC chargers, the works. Also, torque settings for the screwdrivers. All right, lastly, the mount. The mount is actually sold separately. Vising the mount, the design is sublime. It works so well. You can mount it like this, like this, like this, like whatever. There are all the mounting holes. You mount it in place, put the DC hub, mount the DC hub in place, and then these little sections here, these T's, are for, and what you do is you simply loop a cable tie around it and give it a little tighten. That prevents any breakage. So, I've seen it in wiring where you've got this in the car, okay? And what happens with this that are not properly secured in the car, you get a certain amount of flex and movement, and after a while you get a break here and you get a failure of one of the systems. That's what these are for. They're very, very important in a high vibration environment. Right, what else? Why wouldn't I fit a DC hub into my four-wheel drive? Am I going to save money? Well, you're going to save a lot of labor costs, so if you're having somebody else build your system for you, then it's a no-brainer. You're going to save money, and it's going to be easy, or diagnostics is going to be far easier because you don't have fuses all over the place. You have them all in one place, as I've mentioned. Are you going to save money? And let's say you're an experienced person, you've done electrical installs before. Is it worth doing it money-wise? Well, if you want the diagnostics, if that's important to you, then yes. But if you're doing it yourself and you're experienced and you're wiring it yourself, you kind of know what's going on with your vehicle. You might very well say, well, I kind of like the diagnostics, but I don't really need it because I know what's going on anyway. I've got quite a bit of space. I'm not really going to, I'm not I don't have a big problem with space that I would save fitting a DC hub. How much is it going to cost you in reality? So it's these components compared to this one component. Is it going to save you money? No. it's going to cost you more. Not a lot more. Maybe $150, maybe. So it's not a lot more. So what you're buying, actually spending $150. That's actually what it's costing you, $150. Everybody else is saving quite a lot of money, actually. It's difficult to put a number on it because if you've got a very complicated installation, saving you a packet. If you have a simple installation, might not save you anything, but hey, next time you want to add something to your car, you don't have to take it to the workshop. Just do it yourself. Just run it to there. All right. There you go. See you next time. And thank you so much for watching.